Everybody, let's start chemical bonding. What do you mean by a bond? The class should be interactive, alright? Everybody, online, offline, let the class be interactive. You can speak with me and online you can chat with me, okay? What do you understand by the term bond?
It is the attractive force between the two atoms in a molecule.
Okay, anybody?
Two atoms are activated.
Okay, something like joining or something? Okay, so these bonds are attractive forces between the atoms in a molecule or among the molecules in a chemical. Okay, that is called as chemical bond. Now, there are some type of bonds and all, and let's see why these bonds are getting formed. Okay, very simply, molecules are groups of atoms held together in stable conformation by chemical bonds. Compounds are group of molecules, and how do they stay together? By chemical bonds. Okay. Bonding is a natural way to get stability. When the chemicals and atoms bond together, they become stable or they are unstable. That is the reason always molecules are present, always chemicals are present, not individual atoms. Whenever they find the matching, they get and start the bonding with them to get stabilized. Okay. There is something called as octet rule. What is octet rule? Have you heard of it? Okay, what do you understand by octet rule? Online, offline, what do you understand by octet rule?
The last should complete.
Okay, last shell. Anybody else?
All noble gases have opposite configuration.
Okay. But you can tell your own answers. No, there is nothing wrong, right and wrong. Because whatever is listed in atoms is just a probability and concepts and theories. Nobody has seen electrons moving and all, right? It's a concept. You can tell your own concepts, no problem. What it may be octet? Something to do with 8 number. Octa stands for 8. Something to do with 8 number rule. What is this 8 number? In the valence shell, what do you mean understand by valence shell? Outermost shell. Which shell is it? It's only P shell. The octet rule only holds good for P shell or P orbital, not for S, not for D, not for F, only for the P. Okay? This is a concept. It's not a proved hypothesis. A hypothesis, not a proven fact. Okay? To explain certain phenomena, scientists came up with the octet rule. To explain some basic bondings, carbon, oxygen, nitrogen, calcium, phosphorus, such basic atoms what we do use regularly. To explain the bonding in them, they use the term octet. This doesn't hold good for hydrogen, doesn't hold good for helium, doesn't hold good for transition metals, which are the higher end after 60-70 molecular weight. Iron, aluminium, cobalt, nickel, they do not follow the octet rule. And the uranium, all those very high molecular weights. Okay, fine. What happens here? Atoms will gain an electron or lose an electron to form ionic compounds. Okay, and
After is only for p orbitals.
only for p orbitals. Okay. Now, the basic understanding or the basic concept behind octet is ion formation. If they gain an electron, they become negatively charged, are called as anions. If they lose electron, they become cations. This is the basic idea behind octet. Okay? Now, let's go forward. What exactly meant by octet? Good afternoon, Poonam. We just started with the chemical bonding. Okay? Nothing much has been done, just a basic intro. Now, there are various theories have been put up to explain these everything, all those things. Okay? Now, which are the different theories? First theory is Kessel and Lewis approach. This is the first theory to explain chemical bonding. Alright, called as Kessel and Lewis approach. Next is the VSEPR, valence shell electron pair repulsion. Okay, what do you understand by this? The term there?
The valence electrons
Repel each other. That's it. Explain how do they repel. That's it. Okay. Some atoms some bonds can be explained by the first rule, and some other bonds are explained by second rule, and remaining some are explained by valence bond theory. The valency electrons participate in the bond formation, that is told by valence bond theory. Now, last it comes molecular orbital theory. Okay, there's the four. So far, only four are there. We don't know how many are yet to come. Just the theories, concepts. Okay, nobody knows for sure. So I'm not going in detail about all these structures and how do they function because it's a pure chemistry subject. Okay, you just have to know that all these theories are there. Fine. Now, valence electron means electron in the outermost energy level. That is called as valence electron. Now, let us go back to octet rule. Atoms share or donate valence electrons. Okay, to attain 8 electrons in outermost shell. Which shell it is? P shell. To gain 8 electrons. If they get 8 electrons, what will happen? 2s2, 2p6. Total is 8. All shells are filled up. All are paired up. They are satisfied now. So the bond becomes stable and chemical becomes stable. Okay. Now let's see with the help of an oxygen molecule. What happens here? It has 2s2. Sorry, it should have been 2p4. Okay. It becomes 2p6 later. We have 2 electrons here in 2s2 orbit, and here 2px, 2py, 2pz. One is there. So to attain octet, how many electrons does it need? 2 electrons. Which are those? Here and here. Right? So what happens? Electrons here somewhere. This one and this one. These 12 electrons in somewhere outer space. Maybe somewhere in the other atom, other molecule. It shares those electrons. It will come and bind here. One orbit is filled up there. It needs one more. One more is coming there. One more got filled up. Totally how many electrons are there now in that box? 8 electrons. Octet rule is satisfied. Oxygen atom is now satisfied. It's stable. So how it got 2 electrons? By forming 2 bonds. Maybe from 2 hydrogen atoms, from other 2 carbon atoms, it forms 2 bonds and becomes stable. Fine. Yeah, Aditi, these theories are not important from life science point of view. Okay, just know the names. That's enough. You don't have to worry much about them. They're just theories explained by quantum mechanics. And due to this reason, octet rule, noble gases are stable. All noble gases. Okay. Good afternoon, Deepika. What are noble gases? Which are noble gases? Okay. Why they are called as noble gases or inert gases?
They are very stable, they do not not that much.
They
There are all kind of answers coming. Participate, don't participate much. Autonomous electron is filled up. They are showing octet structure. All argon, neon, helium. Not xenon. Never write xenon. Xenon doesn't show octet structure. It's an exception. Okay. Xenon, fluorine, all those do not follow. Okay. Now that's why sodium Na plus it becomes plus 1 electron. Why plus 1 electron? Right sodium configuration, everybody. Sodium configuration of sodium Na. Electronic configuration 1s2, 2s2. Write it. How much? Yes, Pandan. My question is why sodium loses only 1 electron to become Na plus? You never have Na plus 2. Why? Yeah, what happened when you wrote? 3s1 is there, right? So if it loses 1 electron, it becomes stable, 3p6. That's why always Na plus is there. Na plus 2 is never there. Okay? Also same case with calcium. Calcium plus 2 loses 2 electron to become stable. Alright? Calcium can be plus 1 and plus 2, never plus 3. Okay. Some exceptions, it only considers S and P orbital. Okay? Hydrogen and helium have only S orbital with 2 electrons. They don't have P orbital at all, but still they are stable. Helium is stable, hydrogen is stable. They do not follow octet rule. Many elements do not follow octet rule yet stable. Transition metals, higher end metals, rare earth metals, all those uranium, plutonium, thromium, they do not follow octet rule. Okay. Also iron, all metals, heavy metals. Now let's go forward to see what are covalent bonds. I want this to be answered by you guys, both offline and online. Very basic understanding. What do you mean by covalent bond, online students? Yeah, it's already written there. Give me in your own terms. Covalent bond, sharing of electrons. Why do they share?
Space stability.
How do they get stability?
Sharing of
The outermost shell will be completely
Which rule is it?
octet.
Octet rule. Simple. Covalent bond is over. Just share an outermost electron to get stability according to octet rule. Work is done. Task is done. If they share one pair of electron, it's called as single bond. If they share two pairs, that is 4 electron, it is double bond. Very simple. And where do you find covalent bonds? Example of any covalent bond? Anybody? Online, offline? Peptide bonds, okay. Examples of covalent bond, where do you find them? You can tell chemical names also. Bond between this and that, something like that. Everyone has to tell one name. Okay, carbon dioxide over. Anyone? Everyone has to tell one name.
Methane.
Methane. Okay, which bond? Where?
Between carbon and four hydrogen molecules.
Okay. Then come up first.
Oxygen.
No. Only one option? Huh? Water. Where? Which bond?
Hydrogen.
Hydrogen, oxygen. Okay. Then anybody else? First, come on. Ozone. Which bond? Okay. Then ammonia. Which bond?
Nitrogen.
Hydrogen. Okay. Then
Hydrogen molecule.
only once. It's very easy. All chemicals you know all the bond by covalent bonds. You can tell any chemical name, right? Fine then. Okay. The configuration of all these basic metals. Lithium forms +1 because it has only one electron here. If it loses, it becomes stable, like helium. Okay. And beryllium, it has 2 electron extra in S. If it loses those two, becomes helium, stable. It doesn't become helium, it attains helium configuration. 1s2, 2s2, 2p6. Okay. Now, this one, boron, has 3 electrons here. If it loses all 3, it becomes stable. What is this? Nitrogen, it has 5. It needs how many more? 3 more. So nitrogen bonds with 3, nitrogen has 3 bonds. NH3, right? Yeah, Aditi? What is the query? Yes. There are some metals and non-metals which can either form covalent as well as ionic. Okay. Then oxygen, it has how many? It has 6. It needs 2 more. Oxygen forms double bonds to get 2 electrons. Very simple case. The same case here. See, carbon, it has 4 electrons. These black electrons are carbon ones. Okay, black ones, and red ones are oxygens. Now, what oxygen did? It wanted 2 electrons, right? Even carbon wanted 2 electrons. Sorry, 4 electrons in total. So what they did now? Oxygen told to carbon, okay guys, I will give you 2 electrons. Now they share the 2 electrons between them. What carbon did? Okay, I will also share my electrons with you. Now how many electrons it has here? 4. On this side, 4. So count totally how many electrons oxygen possesses now? 1, 2, 3, 4, 5, 6, 7, 8. Octet. What about carbon? 1, 2, 3, 4, 5, 6, 7, 8. Octet. Here also 4 and here 4. All 3 are satisfied. Mutual understanding. Right? This is what we need to have in our life also. Fine now. Let's go forward. It's a small animation. See, this class is not such a hardcore science class. Just to rebrush your already what you know. That's it. Okay. And everything hardcore starts from next week when I enter operon and chromosomes. Okay. Be ready for that classes. Online students, I do understand covalent bonds and octet rule. Any doubt in that? Any doubt, please let me know. It's taking a little time. Let's go forward then. It's taking a little time. Just make a note of it, okay? No, Anuja. Directly chemistry questions will not be asked, but the blend question will be asked. Mixture of life science and chemistry. They will need to apply all these rules, octet and these chemical bond theories, and you need to answer the life science questions. It will be a mixture of questions in part C especially. This won't come in part B. It will come in part C. To answer those parts, you need to have basic of chemical bond. How a covalent bond is formed by sharing. Why it shares octet? So this must be the reason. You need to deduce like that. Okay. So don't have to go in very in detail. Just a basic understanding. Just note here. Can you figure out something? Analyze this data. This is what you're going to do after when you go to PhD, right? Get data, analyze. Get data, analyze for 5 years. Can you find anything? Any inferences? If it is, what is inference? 1 second. Okay, we'll go for this later. Yeah. Online students, please go through this. Any inferences can you draw from the given data? Energy required to break the bond. Okay? This is the bond length, this is the bond type. Okay, triple bond has highest energy. Okay. Number of bonds, fine. Yeah. Because forming the bond is equal to breaking the bond. Both are same. So you can consider them as a formation of bonds. It will be same as that. So what does it say? See. C double bond C, the shortest bond. Leave of hydrogen and this one. Among carbon bonds, C triple bond is the shortest one with 120 picometer distance. What is 1 picometer meaning?
10 to the power of
Minus 12. What about minus 15? What it is called? Huh? Femtone. Okay. Right. C is single bond C. Bond length is 154. Energy is 348. Now C double bond C. Atoms came little closer, right? Energy required to break them is little higher. It's almost double that, almost 600, right? Now formed triple bond. Atoms became still closer, sharing how many electrons here? Triple bond case. 6 electrons. Atoms are very close together, held very tightly. You need lot of energy to break them, right? Now, and HO bond, no. CN is a very weak bond, 308 kilojoule per mole. Now, this is diagram representation. Covalent bond, single hydrogen, single covalent bonds, they're sharing an electron. Okay. Now, double covalent bond, oxygen sharing up 2 pair of electrons, triple sharing 6 electrons. Okay. Let's see if something has opened here. This one was. What's happening there?
The chemical reactivity of an atom is based on the number of electrons the atom contains in its outermost electron shell. Electron shells are depicted here as circles around the nuclei of the atoms. Each shell contains electrons with particular energy levels. Let's examine the electron shells of the element argon. The first electron shell holds just 2 electrons. These are electrons at the lowest energy level, the shell that electrons of an atom fill first. The next 2 shells can each hold 8 electrons. Argon's third and outermost shell is already filled to capacity, making this element extremely unreactive or inert. Chlorine also has electrons in 3 electron shells, but its third shell contains only 7 electrons. In chemical reactions, chlorine has a tendency to gain an electron, filling this shell with 8 electrons. This tendency to fill the outermost electron shell with 8 electrons is known as the octet rule. Sodium has electrons in 3 electron shells, but its outermost shell contains just 1 electron. Sodium cannot receive 7 additional electrons to complete this shell. This would require a huge amount of energy. Instead, sodium has a tendency to lose its outermost electron, leaving this atom with 2 filled inner shells. In general, elements with filled outer shells are inert, but atoms of all the other elements are chemically reactive and can form chemical bonds with other atoms. A chemical bond is an attractive force between atoms. Bond formation relies on the ability of atoms to share, donate, or receive electrons from other atoms. Let's examine the nature of a chemical bond using hydrogen atoms as examples. 2 atoms are depicted with their electron shells. 2 others are depicted more realistically, showing a region of space around the nucleus where the electron has a high probability of being found. This region is an electron's orbital. If 2 hydrogen atoms approach each other, the positively charged nucleus of one is attracted to the negatively charged electron of the other. The orbitals merge, and the electrons are then equally attracted to and shared by the 2 nuclei. The electron-rich region between the nuclei binds the atoms together.
Understood now how the bond is formed? Electron is shared or attracted same by both the nucleus. Fine. Look for covalent bonding. On then students, is it clear? Everybody? Octet rule and how the bond is formed? Okay, let's watch one more video of covalent bonds.
A covalent bond results when 2 atoms share electrons. In the case of 2 hydrogen atoms, each shares its single electron with the other. This sharing allows each to fill its electron shell with 2 electrons. The pair of shared electrons constitutes a covalent single bond. Let's now consider oxygen, an atom with 8 electrons. 2 electrons fill the innermost shell, and the other 6 electrons reside in the next shell. This outer shell needs 2 more electrons to complete it, the octet rule. 2 oxygen atoms form a covalent double bond by sharing 2 electron pairs from their outer shells. Carbon is perhaps the most versatile element on Earth, in large part because it contains only 4 electrons in a shell that can hold 8. To fill its outer shell, carbon forms 4 covalent bonds with up to 4 other atoms. In a molecule of methane, carbon shares electrons with hydrogen atoms, forming 4 covalent single bonds. Although this molecule is relatively simple, carbon often forms the backbone of large, complex molecules. With each carbon atom able to bond to 4 other atoms, carbon-based molecules are incredibly diverse. Triple bonds are rare, but nitrogen gas molecules, the most abundant molecule in the air we breathe, form triple bonds. The 2 nitrogen atoms share 3 pairs of electrons, allowing each to have 8 electrons in its outermost electron shell.
Okay, let's go back to our presentation. Everybody clear? Offline, online? Any doubt in this? Now quickly let's go forward. ionic bonds. A very simple bonds formed by attraction of oppositely charged ion. Na became Na plus and Cl became Cl minus. Now if one is plus, one is minus. Attraction between them formed a ionic bond. Okay, and these ionic bonds form a crystalline structure. Okay, and these ionic bonds are formed between salts. What is a salt? What is called as salt? What do you mean by salt? Not normal salt what you use at home. That's a salt. But what actually is meant by salt? Acid and base. They mix up to form salt. Okay. Any other explanation for salt? Any compound having a mixture of a cation and an anion. Na plus, Cl minus. They mix up to form a salt. Okay. Metal and non-metallic. Okay. No, it is not metal and not metallic. Okay. It can be said in case of NaCl and KCl and all, but in general, salt refers to a bond formed. It's a compound formed by the cation and anion combination. Okay, having an ionic bond in between. Can you solve this question? Somebody is searching for some friend to figure out who is that and who is the friend. Can you hear me, Poonam, now? Am I audible? Okay, Poonam, I guess your own speaker has been turned on, the mic. Please shut it off. Your mic has been turned on, I think. If it is so, shut it off. Sodium and chloride. How can we be so sure, Sachin? It can be potassium and chloride also. Simple. Anion. And who is anion here? You or your friend? Friend is anion. What about you? Friend is anion and you are cation. Right? Anion has a positive charge, has a negative charge. Now, what is electronegativity? It's affinity for electrons. Very simple. Differences in electronegativity dictate how electrons are distributed in covalent bonds. Okay, the difference in the electronegativity between the bonds. If carbon and hydrogen are bonded together, who is more electronegative between carbon and hydrogen? Nobody. What about oxygen and hydrogen? Is more electronegative. So what oxygen does? It plays a major role in covalent bond formation. It wants electrons. It's electronegative. What happens in that case? Non-polar covalent bonds, equal sharing of electrons between carbon and hydrogen. They have same electronegativity. Electrons are equally shared. These shared pair of electrons here, here will be equally shared between those two. They lie exactly in the center of those two atoms. In case of non-polar, in case of polar covalent bond, these oxygen, the atoms here, electrons, they shift to one side towards oxygen. They shift towards oxygen because oxygen is electronegative. So it gives rise to partial negative charge on oxygen, partial positive charge on hydrogen, OH. Okay. Polar results due to unequal sharing of electrons and non-polar equal sharing of electrons. Okay. Why water is called a polar solvent? Water is a polar or non-polar?
Polar.
Why polar?
Because the oxygen will be like delta minus will be there, and hydrogen will be having delta one, I mean plus.
Why?
Because oxygen is more electronegative, it snatches electron from hydrogen.
Exactly, it becomes a non-polar covalent bond, O and H. So oxygen gets slightly negative charge, H gets slightly positive charge. Polarity is distributed, is formed now. So water as a whole has a negative charge and a positive charge. So we call water a polar solvent. Okay. Aditi, shall we go forward? Okay. Now let's go here. The previous one was nothing, just a repetition. Okay. Now let's go to van der Waals interactions. What do you have basic idea about van der Waals? I want to know that. What understanding you have about van der Waals? Everybody, online, offline. Tell me what you already know about van der Waals. Everybody. Okay, weak interactions. Then intermolecular. Okay. Then maybe intramolecular also. Okay.
Molecules, one of them is slightly electropositive,
Electronegative. Okay.
It's one to
Okay.
water is molecules.
Yeah, you have something coming closer. Yeah. Adjacent atoms, this happens. Right? Now let's go. Exactly. In various molecules, it happens in various molecules. Yeah, van der Waals are very weak interactions in the universe, okay? But they are very important interactions. They play a major role when atoms are very close to each other. They play a major role. Other than covalent and ionic interactions, van der Waals interaction keep chemicals together, keep molecules together, okay? And have you heard that the gecko, the climbing spark lizard, how it climbs the wall, how it holds the wall so easily? Even the wall is very smooth, even the glass is, it can even hold on glass surface. How? Using van der Waals interactions. The atoms present on the glass surface and the atoms present in the lizard's palm, they build up a van der Waals interactions. Temporary interaction, because of which the gecko means a lizard, it can hold on to wall very firmly. Even though a man pulls its tail, the lizard will not fall down. So in earlier times, the lizard was used by the thieves to climb the big walls or climb the ships and all, because it can hold very firmly. It will not leave its foot. It will never come because it uses van der Waals interactions. They are very firm at very closer range. Okay. No, it's not due to vacuum. It's due to van der Waals interactions. Now, there are three types of van der Waals interactions. The name van der Waals is the name of a scientist. Okay, it's not a wonderful wall. It's not that. It's van der Waals, name of a scientist. Right? There are three types of interactions: London forces, dipole interactions, and hydrogen bonds. Okay. Now let's see what are London. I tried a little bit to make a small animation. I don't know how much it worked out. Let's see. Yeah, wait, Sachin, I'm going for that. London forces. Okay. These are the two inert atoms, neon and neon. Basically, they do not interact. Why don't they interact?
They have a
Octet, filled up, satisfied. They are not hungry now. After maybe post-lunch session, nobody is hungry. Yeah. Neon and neon. In the meanwhile, if they happen to come close together, neon and neon, they build up some kind of interaction between themselves. And those interactions are called as London forces. Interactions between the satisfied atoms or noble gases, helium, neon, argon, they build up some kind of interatomic interactions. Okay. Now what happens here? These are the electrons around neon, equally distributed. Okay. Now electrons always rotating, maybe moving somewhere, we don't know exactly. Somewhere they are going somewhere. There is a possibility that electrons may clump in a single site at a fraction of a second, and in this molecule electron will clump in the opposite side in a fraction of a second during their constant random motion. In that case, what happens? In a fraction of time, the neon on this face gets a partial positive charge devoid of electrons. On this face, it gets a partial negative charge. Whereas here, This gets a partial negative charge bottom and partial positive charge in this region. No electrons in that region. Okay. If very rare, if this happens, the positive charge of the positive region of neon gets attracted to negative region of this neon atom, and they build some kind of interatomic interactions. That is called as London forces. Okay, understood? Can anybody explain me? Online students, is it understood? Yes, it is temporary and very weak. Okay, let me get it one more time. These two are the neon atoms. Okay, they are inert and they will not react with anybody. They are very happy. Now they have 8 electrons around them, equally shared. But electrons are not equally shared, or electrons will never be at static. They are always in random motion, moving with the speed of light. Okay, and in a random motion like this, something they are moving something like this. Okay, in a random momental time, in a fraction of second, there is a possibility that all the electrons of neon can clump in a single side, giving it a partial negative charge, and on the other side where there is no electron, giving a partial positive charge, a temporary. Okay, now on the one more molecule, one more atom neon, maybe same case happens, electron clump in one side giving partial negative charge, on other side there is no electrons giving partial positive charge. In that fraction of time, there is a possibility that these two regions, delta positive and delta negative, may form a bonding, a weak and temporary bonding, that is called as London forces. Okay, as long as the bonding takes place, they will be together. The moment any external force comes in between and pulls the neon somewhere, the bond is broken up. Very weak. Alright, is it clear everybody? Aditi, Anuja, Poonam, Sachin, is it clear? Offline students, everybody clear?
Only in the process.
Which one? Yeah, because neon always stays in gaseous state in room temperature.
No, only in a molecule or
Yeah, only, especially inert molecules, especially inert molecules. Because if other molecule comes in between, they form other kind of bonds, covalent or ionic, some other kind of bonds, dative bonds, covalent bonds, right? But in these satisfied atoms, only these can form. Either hydrogen bond can be formed, or dipole interactions can be formed, or London forces can be formed. Okay? Fine. Let's go forward for next one. Dipole-dipole interactions. What do you mean by a dipole? Dipole, the word has, yeah.
it's a separation between positive and negative.
Negative charge, very simple. Positive and negative charges separated by some distance. Yeah, they call it dipole. Now, this is a molecule, HCl molecule. This is the one more HCl molecule. And this is a permanent bond, covalent bond. The line here, okay, these two are permanent bonds. And something dot dot line is some kind of interaction between them. How that interaction came? Now, as I told you earlier, chlorine is slightly electronegative. There are 2 electrons in between them, right? Single bond, 2 electrons. Now, chlorine, because of electronegativity, pulls these 2 electrons towards itself. Pulls the chlorine, all the shared electrons. Now, what happens? Chlorine gets a partial negative charge. Due to losing its electron, hydrogen gets partial positive charge. Same case happens here. Chlorine pulls its electron towards itself because of electronegativity. Chlorine gets negative, hydrogen becomes partially positive. Okay? What do you mean by partial positive, partial negative? What's the actual meaning of it?
It doesn't lose its electron completely. It only at a time, what to say, chlorine snatches electron towards itself. Actually, hydrogen is not going to lose electron.
Exactly. It's going somewhere away. The electron from hydrogen's orbit, it entering the chlorine orbit. It's moving, it is spending more of its time towards chlorine, not with the hydrogen. Spending more time with chlorine than hydrogen. So hydrogen, what hydrogen will feel? Okay, I have no electron. So it becomes a partial positive. What chlorine will feel? I have extra electron right now. Okay, it becomes a partial negative. Okay. In that case, what happens here? The chlorine partial negative, hydrogen partial positive may build up an interaction. ionic interactions, attraction plus and minus, and this is called as dipole interactions. This is a dipole, this is a dipole. Dipole interaction. Okay, clear everybody? Online students, is this clear? Exactly, movement of electrons cause partial charges due to electronegative chlorine. Okay, yeah, it is similar to hydrogen bonding. Now let's go. Let's see what is hydrogen bond. Hydrogens are bond formed between only hydrogen atom and electronegative atom. What about here? Dipole interaction. It need not be hydrogen and chlorine. It can be any electronegative atom, oxygen, chlorine, nitrogen, fluorine, and any less electronegative atom, hydrogen or sodium, anybody. Okay, it need not be hydrogen. But if it forms with hydrogen and other electronegative atom, it is called as hydrogen bond. Very simple. It's almost similar to dipole interaction. Hydrogen bonds are, and they work out in water molecules very well, giving water beautiful characteristics, right? And look at here, hydrogen bond length is 1.97 angstrom, covalent bond length 0.96 angstrom. 1.97, 1.98 almost, that range. That is the range of hydrogen bonds. Now, why do we study about hydrogen bonds? What is the necessity? Everybody, online, offline, can you tell me some importance of hydrogen bonding in biology? Let's come back to biology from chemistry now.
In proteins we can have in nucleic acids.
Okay.
Soluble something in water at the solution we require this hydrogen bond.
Okay. They play a role in solubilization. Okay. Then.
All other molecules are hydrates of carbon.
Okay. Even they form hydrogen bonding. Okay. Then. I'm not asking, I'm just discussing with you. Where do we find hydrogen bonding in our biology? That's it. Like proteins, DNA, yeah. Nucleic acids, exactly. Where is nucleic acid? In DNA to stabilize the molecules, right? Double helix stabilization, right? Exactly. In DNA, RNA, proteins, yeah. Whichever molecule you take up in life sciences, all are having some kind of hydrogen bonding. Okay. Now, what are hydrophobic interactions? What do you mean by hydrophobic interactions? It is there. You can read and tell me. Hydrophobic interactions. Online students, what do you understand by hydrophobic interactions? Exactly, very simple. They repel water. Hydro means water, phobic means water. Fear, phobia. They have a water phobia. They don't come and mix with water. Simple, nothing much in that. Task is done. Right? Now, water is a polar molecule, and any compound to dissolve in water should be a polar molecule. Non-polar molecules will not dissolve in the water. Okay? Now, can you tell me why sugar dissolves in water? It's a question.
Has OH bonds.
Okay?
So that's soda. That's easy.
Where it has OH bond?
If you make glucose,
Hmm.
so that's OH.
OH and H. Okay.
So that OH, that easily gets dissolved.
OH has a minus. Well, what about plus? If OH becomes minus, somebody has to become plus in that glucose. Which becomes plus? You got my question? If OH has to become minus, somebody has to there to donate electron to become plus. Yeah.
You could one C6H12O6 just some H2O just regularly breaking the bonds and forming the bonds.
Hmm.
Union and so those hydrogen bonds will put up this oxygen molecules and
You form H plus and OH minus, you mean to say?
no, they are forming bonds. They are trying to not
Hmm.
Actually, I don't know.
Okay, whatever you told was something good. Right. Just think on it, everybody. Why sugar may dissolve? If OH becomes minus, yes, OH becomes minus. Who becomes plus? Indeed, I have not mentioned which becomes plus, what does that chemical happen? You need to find out that. Okay? Is a physical property, why it dissolves? Chemically, you need to find out. It's a homework for you, everybody. Alright? Online, offline students, find out the chemical nature, why chemically it dissolves. This is a physical I have explained here. Sugar is a polar molecule. And why it is polar, you need to tell me. Why it is sugar is polar. Okay? What is a polar molecule? You know it very well. Polar will dissolve, forming a hydrogen bonding. Right? The sugar molecule, when you add sugar to make tea, the sugar atoms will break down, forming hydrogen bonds, and water molecule will come here, encircling the molecule, right, encapsulating it so that the sugar atoms are now dissolved. Okay. Just a funny code, not nothing much here. You understand the humor? That's fine. Then the task is done. Fine. Now tell me why solid is solid at room temperature. Why this laptop is not melting? Which is very funny, but it has a lot of understanding. Yes, compact arrangement. Why? In room temperature, why solid will not suddenly melt down? Why do we do not melt down suddenly? Why humans do not melt? In Terminator they show, right? Terminator Part 3, it melts suddenly. Yeah.
It will only at the temperature of
Hmm.
the saturation temperature.
Okay. Strong bonds, proper bonding. Yes, of course, bonding will be there. Yes, come on. There are plenty, lot of expressions for this. You can tell any option. Something about bond, something about energy, something about bond breakage, something about activation energy. Okay, no energy to break the bond between atoms. Okay, they are stable at room temperature. Okay, yes, see, they are leading online guys. Offline, let's have a competition between offline and online. Let's see who is more active.
Different density volume structure of the atom.
Okay,
The density is more, volume is less.
still solid. Okay.
So the concept ratio.
Yeah, even that may be the reason. Then, it's a physical reason. What about chemical reason?
If they form interconnections,
Hmm.
there would be solid state means crystals, solid crystals.
Yeah.
They
Okay. I'll give you a clue. Water becomes steam when you heat it. Why it becomes steam? Bonds are getting broken. How they got broken? Energy is given from external sources. It got energy, bond is broken up, and atoms became free. Very simple. Right? If you heat this laptop, this plastic material at certain temperature, bonds will break up and this laptop will melt down. Right? If you burn the human body at certain temperature, it will get converted to ash and fumes. How converted to fumes? So bond breakage, carbon-carbon bond breakage. Right? Now what happens here? Energy supplied by thermal energy. What's the temperature? 22. Okay, 25 degrees Celsius is 0.6 kilocalorie per mole. Energy of a room temperature, that is 25 degrees Celsius. If there is a temperature of the room now, energy supplied by air molecules or air atoms to every atom of your body is 0.6 kilocalorie per mole continuously. They collide or they hit, do something, they give that much of energy. Okay. Energy required to break a carbon-carbon single bond is 84 kilocalorie per mole. How many times more? 150 times more almost, right? That means what? You need to raise the temperature, maybe to 80 or 90 degrees Celsius. to break that bond. Okay, this is the reason. That's why solids will remain solid and liquids remain liquid, gases remain gases at room temperature. You change the temperature, everything will change. Why it will change? Because energy supplied by the air molecules or surrounding atoms on these bonds increases as you increase temperature. If it is 0.6 at 25, if you increase to 30, it may be 0.7 or 0.8. If you increase to 100, it may become 10 or 15. Okay, breaking some hydrogen bonds. Fine. Now, the last only a couple of slides are remaining. Why oil and water do not mix? Hydrophobic interaction between whom? Oil and water. Okay. If they do not mix, which will form the upper layer? Sure. Oil. Why oil? Density is less. Oil density is less. So this was just I told you. Lizard holds on to walls so firmly with using van der Waals bonds. What kind of bonds? Van der Waals bonds. What is the funda of curling hair? There's some curling hair technique in saloon that I guess you might have tried some once. If you go there, they can curl your hair, curly. Usually girls do that, right? What is the funda behind the curling of hair? How you can artificially curl your hair? Yes, of course they heat your head, but how? Exactly, heating, but how?
But they break the bonds.
Something he told. Keratin, somebody said keratin? Yeah, something to do with keratin and hair protein. How? What happens actually? Protein denatures. And the hair should grow deeper. You should lose your hair. Yeah, something to do with bonds and proteins in the hair. What exactly happens? It's a very general question. You use it daily, regularly. What do you do? What kind of bonds are there between amino acids? Between chains? Or between the protein molecule? What kind of bonds are there between polypeptide? Okay, which is some specific bonds are there in protein? No, some, of course peptide, something special other bond. Disulfide bonds. Yes, double bond S. Disulfide bonds are there. They are present only in, especially proteins molecule, in keratins. What do? They heat the hair. I don't know. I have not seen how do they heat, but heat the hair. Okay. What happens in that case? All these disulfide bonds are broken up, and they add a alkaline agent. They add some cream like this. They add a cream. It contains a highly alkaline solution or agent. What it does? It creates random disulfide bonds. Very close random disulfide bonds. Alkaline solution reduces the sulfide so that they will form a bond. Reaction happens. Then close disulfide bonds, curling of amino acid chain, curling of alpha helix, curve up together, beta loops are formed, alpha chains loop up, giving rise to curved hair. These all things happen in curling of hair. Fine. Alkaline solution reduces sulfur, sulfur will form a bond, immediate bonds, formation of immediate bond, alpha helix folds up completely, folding alpha helix loops up, giving rise to total curled hair.
They even heat the hair for straightening.
Yeah, even hair for straightening. They don't add alkaline solution. That's it. If you don't add alkaline solution, it will remain straight.
How is that alkaline helpful? I mean, it tends sulfur to form.
Yeah, because alkaline is a solution, it reduces the sulfur atom. How we can reduce sulfur atom? By providing electrons. When you provide electrons, it reduces. Any compound, if you remove electron, it becomes oxidized. If you add electron, it becomes reduces. It has excess electrons now. What to do with excess electrons? Let's make a bond. Let's have a bond with sulfur and let's share the electrons. That means this reduce their negative charge. Okay? Fine, let's go forward. In which type of bond electrons have been donated by one atom to another? Don't tell because they are telling. If you tell, you need to justify the answer. Okay, online students, why it is ionic? Justify your answers. Why ionic? Yeah. Why not covalent, polar covalent? Polar covalent. Unequal sharing. Why not the case? What I told is correct. Ionic itself. But why only ionic? Why not in polar covalent?
They don't lose their control.
Exactly. They don't lose the control over electron. They just share unequally. It's not lost completely from the orbit. It's sometimes entering the orbit also sometimes. It's not completely lost.